This is part 3 of section 3.5. I want to end up graphing this rational function. You may notice over here that I rescaled the graph. I made each line worth 1/2, and that's because this graph is pretty detailed. We need to be able to do a little bit more, okay? Now, I know our first step is to find the symmetry and everything else, but if you look at this and you see that it is going to reduce, and it definitely is, this is the same as x minus 2, which does not factor, over, this is a difference of squares, so x plus 2, x minus 2, 1 over x plus 2 is what we have left. Now we can use the reduced version for everything except for finding holes. When we're looking for holes, we have to come back up here, okay? So, first step. Look for symmetry. Now I'm going to plug in f of negative x and see what I get, and I can use my reduced version. Well, that gives me 1 over negative x plus 2, which is definitely not the same as this, so it's not even. We don't have symmetry about the y-axis. If I factor out a negative from the whole thing, now remember with a fraction that negative 1/2 is the same thing as having a negative 1 over 2, which is the same thing as 1 over negative 2. It doesn't matter whether the negative is in the top and the bottom or off to the side. And that's because it's division. It doesn't matter. You get the same answer when you're dividing a negative over a positive as you would with a positive over a negative if the other numbers are the same. So I'm going to factor a negative out of the bottom here. And then that's the same as having that negative off to the side. And then you look, is this the same as this without the negative? And the answer is no. So no symmetry here. It's nice when you can get it, but you can't always get it. So it doesn't really take that long to do. So our next step is to find a y-intercept if we have one, which means finding f of 0. We can use our reduced version here, and that simply gives me 1/2. So I will have the point 0, 1/2. Okay, that's my y-intercept. Okay, now step 3. We are looking for our x-intercepts, if we have any. You can use the reduced version. To find an x-intercept, you set the numerator equal to 0 and solve. Well, 1 can't equal 0, so we have no x-intercepts. Okay, now for 4. 4 is our vertical asymptote and holes. So I'm going to come back up here, okay? Well, actually right here in our reduced form. Not reduced, factored form. So look at your denominator. What makes your denominator 0? What would we have to exclude from the domain if you remember the first problems we did? Well, we would have a problem at x equal to negative 2, and we would have a problem at x equal 2. So both of these would have to be taken out of my domain. Now I just need to decide whether these are holes or if they're vertical asymptotes. And to do that, we look at our final reduced form. Well, only one of these is still a problem in this one, and that is x equal to negative 2. So I'm going to have a vertical asymptote at x equal to negative 2, because this is still an issue in our reduced form. Now we have to worry about this. I'm going to have a hole at x equal to 2. So I need to figure out where that is. And remember, you take this and you plug it into your reduced form. So f of 2 reduced form would give me 1/4. So I have a hole at the point 2, 1/4. Okay. Step 5 is to look for horizontal asymptotes. Okay, remember, you look at your degree And you can look here if it's easier, but it still works here. The degree of the top here is 1. The degree here is 2. Since that makes a proper fraction, 1 over 2, then we know that the x-axis is a horizontal asymptote. Our horizontal asymptote is y equal to 0, which is the x-axis. If you think about doing it here, since this is a constant, that would be a degree of 0 over a degree of 1. It's still, the top is smaller than the bottom. Okay? And normally we would check to see if we ever cross this. And the way we would do that is we would set our original equal to 0, but we actually already did that when we found the x-intercept here. This happens whenever your horizontal asymptote is the x-axis. If we had y equal to 3 or any other horizontal asymptote, I would really need to check to see if it crossed. All right, so since this would be our x-intercepts, and we have no x-intercepts, we never cross it. Okay, so our next step will be to plug in some numbers, but we don't know yet what we need to plug in. So let's start graphing. Okay, I know that I have 0, 1/2 as my y-intercept. And remember, I'm doing these on scales of 1/2. I never cross the x-intercept, no, the x-axis. All right, I have a vertical asymptote at x equal to -2. So a vertical asymptote at -2. And I have a hole at the point 2, 1/4. I'm going to draw this in with colored pen right here. It's a circle. I mean, my graph is going to look like it goes through this point. It just sort of doesn't exist at this one tiny infinitesimally small point. All right, and so I've graphed a hole and I've graphed a vertical asymptote. Now our horizontal asymptote is the x-axis. So I'm going to draw it in just a tiny bit below, so maybe it'll show. And I never touch or cross that either. So I essentially have 2 points. I know this graph will go to infinity by an asymptote, a vertical asymptote. So, and we're not allowed to cross this. So it looks like on this side, there's not really much to plug in, because since I can't cross this and this works like a magnet, it has to be like this. It's going to curve down, hit that, head towards that hole, which maybe I drew a little bit high, skip over it, and then your horizontal asymptote, that magnet starts to take over. I know I didn't draw it beautifully right in here, but you should get the idea. Now for this side of this asymptote, I have to figure out whether my graph is up here or down here. That just means plugging in one more point. Let's try -3. So this is step 6. Let's find f of -3. That will be 1 over -3 plus 2, which ends up just being -1. So I'm going to plot the point -3, -1. -3, -1. Okay, now since these asymptotes work like magnets and they start drawing this in, and I'm not allowed to cross either of them, this graph has to look something like this. Okay, and that should be our answer. On the next problem, we're going to talk about that particular weirdo called the slant asymptote.